surd equation and we need to solve for x. So what is very important is when I am given a surd equation, I need to remember to test my answer. All right, so that's very important because we are going to follow certain steps for us to solve for x. We might get more than one answer, and those answers need to be tested to see whether it will fit and make the left-hand side equal to the right-hand side. So very important, when we have a surd equation, always remember the answers need to be tested. So my first step here is to isolate x. So I want to first make sure to do that. I have to get the surd on its own on the left-hand side, which I have, so that I can go and do the inverse of the square root, and that is to go and square both sides. Now when I do that, I will get rid of the square root and I'm left with only the piece at the bottom, which is x plus 28. And then I want to go and multiply this out. Please be careful here that you have to go and please write this out and multiply it out correctly. That's one of the mistakes that is made quite often when doing these type of sums. So 2 times 2 is 4, and then we have 2 times negative x is negative 2x. Then we have another negative 2x and then a positive x squared. I'm now ready to go and put this in standard form. We can see that this is a quadratic equation, so I want to get it in standard form, and standard form for quadratic equation is ax squared plus bx plus c equal to 0. Now the equal to 0 part can be in any side, so it doesn't matter where the 0 is as long as it's equal to 0, so that I can solve for x. I can do this by means of normal factorization, or I can do this by using the quadratic formula, which is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I can see that I would want to this a value to be a positive, so I'm going to keep it on the right hand side. I'm going to just write it as x squared, and I'm going to put the 0 on this side. So what I want to do is to subtract the x on both sides, so that becomes 0, and then I will have negative 2x, negative 2x, negative x. That will give me a negative 5x. And then what I will do is I will also subtract 28 on both sides, so that I can have 0 on the left hand side. And so I have negative 28 plus the 4, and that will give me a negative 24. Now I'm ready to go and factorize. You are more than welcome to now use the quadratic formula, but this is a very basic quadratic equation which I can easily solve by using factorization. I know that x times x is x squared, and then my factor pair is quite important here, because looking at the factor pair that I currently have there, this negative sign will determine what signs I need to put in the brackets, and that will help me to choose the correct factor pair. Positive times a negative is negative, so the factor pair that I have to put in the brackets needs to add up to give me a negative 5. So there are a number of factor pairs that you can use with 24, but it needs to specifically, when I add them up, give me negative 5. Now in this case, we are going to use the factors of 8 and 3. The reason for that is I need to have two different signs, and when I test this, I know that x times x is x squared. When I multiply the negative 8 with the positive 3, I'll get negative 24. But when I add them up, negative 8 plus the 3 gives me negative 5. And therefore I know that factor pair is correct. So I then would go and say x is equal to positive 8 or x is equal to negative 3. Again, you could have gotten the same answers by putting it into the quadratic formula. A being the positive 1, B being negative 5, and C being negative 24, you would have gotten the same two answers. But remember what I said at the beginning, please remember to test these answers. So you have to go back to the original sum and substitute the 8 in there and substitute the 8 in there and see whether the left and right is equal to. Do the same with the negative 3. Remember to sub using brackets. And when I do that, I find that this 8 does not work, so therefore x is equal to negative 3.